Hey, welcome back. Math with Herlaar, video number 4, squares and square roots. Now, video number 3 had a little bit of square rooting in it. So if you want to get a deeper understanding of roots, I'll throw out a square root basics video as a bonus here. It won't follow the sequence of video 5. I'll just do a quick little square roots video. This one's going to dive a little bit deeper between the relationship between perfect squares and square roots because we're going to dive into Pythagorean theorem, which for those of you that remember involves squaring and square rooting. For those of you that don't, you'll see what happens. So here we go. Welcome back. Thanks for watching. Perfect squares. What's a perfect square? So we're looking at the most important aspect of a perfect square. They have two identical factors. Now, math, I hesitate to say mathematicians because we're definitely not all, I'm not a mathematician. I just do math. But people who come up with mathematical vocabulary, let's say that, are not very original. Okay, we call it a square and we call it a perfect square. Now the number, not the shape, because if you have a square, your sides are the same length, which means you have an area which is 4 times 4. So you get the area of a square. That is a perfect square. So every single number that's a perfect square number just has two identical factors. And you could just go up the list of whole numbers and multiply them by themselves, and you get your list of perfect squares. Now, as I mentioned, this basic piece, I'll do a little bonus video, but this is something I'm hoping you learned a number of years ago. If you didn't, or you forgot, just Google perfect squares or a multiplication table, and you really want to try and nail this down. I say it often to my classes and to parents. If you have a solid understanding of your, let's say, 12s times tables and your basic division from those 12s times tables, I'm confident that you can learn anything in high school, middle school. So if you're not feeling like you're getting that exposure that you didn't get that exposure in your younger years of learning, there's nothing to say you can't pop online and get a worksheet down or um, just start writing down cue cards, flashcards, go on Amazon. I'm sure you could find something and just practice your basic multiplication times tables. I know it seems simple, but it will make your high school math experience, chemistry, science, so much easier. And also, it's just a facet of numeracy that is, it's a good feeling to have in your head. No one likes feeling like they don't understand something. So, how do we get better at something? Well, we practice. It goes for anything, playing instruments or sports or dancing or whatever it is, art. You're not going to get better if you don't practice. So, don't just say, I suck at math, game over, because you just got to practice and you will get better. Take it from me. I've gotten way better at this stuff. I do it every day now. So, perfect square, same number times itself. Okay, now square roots. Well, what does it mean to be a square root then? Well, if I wanted the square root of 144, I'm looking for two identical factors. Pardon my penmanship here. Now, some people might go, well, Herlaar, I know the answer to this. It's easy. It's 12. I learned that already. Awesome. Well, how about I show you, just in case you don't know, how to find it using your factor tree. Remember, your factor tree breaks down into factors. We are looking for two identical factors. Now, if you don't know that this is 12 times 12, well, then you're going to do a little bit more work. And what you're going to do is you might go, well, I can see that it ends in 4, so it's even, so I can divide by 2. You might say, ooh, I can see that it ends in 44, which I can divide by 4, so I can divide the whole number by 4. Those are back to our divisibility rules from video 1. So let's divide by 4. 4 goes into 14 3 times with 2 remainder. 4 goes into 24 6 times. 36 is 4 times 9. And then 9 is 3 times 3. Now you might think, well, why not break those 4s down? But remember, I'm looking for two identical factors, which means I'm looking for two groups of factors. And I have one 4 and I have two 4s. So I'll put a 4 in this group and I'll put a 4 in this group. And then I'm looking for a 3 and a 3. So I'll put a 3 in this group and I'll put a 3 in this group. And you can see that that gives you 12 and 12. That gives you your two identical factors. So if you have two identical factors, the square root is one of them. They combine their powers and they come out together. So you say the square root of 144 is 12 because 12 is an identical factor. That is what makes something a square root. So let's look at these ones. Okay, I just did 144, so maybe I'll throw a different number up here. Let's do, and I'll do it in a way that isn't straightforward. We'll do 81, but here's 576, and you're like, great, that's a big number. But divisibility rules. We chop this thing down like a tree, a few cuts at a time. And just small harvestable trees, okay? We're not logging old growth here. Okay, so divide by 2. 2 goes into 5 twice with 1 remainder. 2 goes into 17 8 times with 1 remainder. 2 goes into 16 8 times. Okay, we're getting there. I can divide by 2 again. 1, 4, 4. Now you may pause here because we just did 144 and go, well, wait a sec. I know that that's 12 times 12. And the reason why you would stop there is because remember, you're looking for 2 groups. You have a 2 and a 2. That covers that and that. And now you have a 12 and a 12. Now you could work all the way down and you'd put them all together. You'd end up back in this place. But you can see that that gives you 24 and 24. So what's the square root of 576? It's 24 because you have 2 identical factors. Now let's look at 81. So say you're like 81 and you don't know. I know some of you are yelling at me right now. It's 9 times 9. Yeah, but if you don't know that, you go, okay, well, 8 plus 1 is 9. I can divide that by 3. 3 goes into 8 twice with 2 remainder. 3 goes into 21 7 times. You're like, well, 27 is 3 times 9, and 9 is 3 times 3. It's like, okay, well, there you go. You have prime factors. You have an even number of them, which means good things. Put 2 3s there. Put 2 3s there. 9 times 9. So the square root of 81 is 9. That is what a square root is. That's how we find it. So the relationship between squares and square roots is an inverse. So you, it's like a zipper. So it's like addition. So 5 plus 2 equals 7. Well, the inverse of addition is subtraction. So you take your result and you do the opposite of what you did, and you get back to 5. Right? So I added 2 and then I subtracted 2. Same with multiplication. 3 times 4 is 12. Well, the inverse of multiplication is division. 12 divided by 4 gets me back to where I started, right? Zip, unzip. Zip, unzip. Well, guess what? Square roots do the same. 4 squared is 16. The square root of 16 gets you back to 4. That's the relationship. Now, if you look a little bit closer, we can use substitution. The square root of 16, well, 16 equals 4 squared. So it's the same as saying the square root of 4 squared is 4, because 4 squared is 16, right? And then you'll notice, well, that's the relationship. The square and the square root cancel each other out. I'll go a little bit more into depth in this in later videos, particularly when we get more into simplifying radicals and we're talking like grade 11, but that is the relationship. A square and a square root cancel each other out. They undo the doing. So how does that relate to Pythagorean theorem? Well, so Pythagoras, and my history is entirely anecdotal, so don't hold me to anything, but rumors are that Pythagoras didn't actually come up with the majority of his theorems. You see, Pythagoras ran a school of mathematics called the Pythagorean School of Mathematics. And the rumor is that his students came up with a lot of these theorems, and he just stole them because he was the teacher. Now, take everything with a grain of salt. It was a long time ago. His name's still on it, so we'll give it to him. But Pythagorean theorem, which what a lot of has to do with what we call a right angle triangle. So a triangle with a 90-degree angle in the corner. Now, most people will remember a squared plus b squared equals c squared. But I like to put a little bit of a disclaimer there, because that's assuming that's an a, that's a b, that's a c. Notation matters. What happens if you looked at a triangle and someone had it labeled like this? It's definitely not a squared plus b squared equals c squared anymore. If you just plug in a formula without knowing what it is you're doing, you're not going to get things right. So be careful there. So what I like to do is I like to call it the leg, and the hypotenuse, because the legs are interchangeable anyways. A and B are interchangeable. Those are the two legs of the triangle, and this is the hypotenuse of the triangle. Remember it that way, and you're never going to get it mixed up. So let's see it in action. Now, there's two things you can do with this theorem. You can use the theorem to prove that a triangle is right, or you can solve for missing information. So the first thing we'll do is we'll prove that a triangle is or is not a right angle triangle. So a lot of people are cheeky and they're like, oh, it's not a right angle triangle because that little triangle, that little box isn't there in the corner. Well, okay, good. How about that could be 90.0001 degrees. So you can't visually see it. You need to trust the mathematics. So we just use substitution here. Remember that this is a leg, and this is your hypotenuse. So Pythagorean theorem tells us that the leg squared plus the leg squared should be equal to the hypotenuse squared. So we just plug in. I have 8 squared plus 6 squared should be equal to 10 squared. So you're not solving, you're just simplifying through. So 8 is 64, 6 squared is 36, 10 squared is 100. 64 plus 36 is 100. Does 100 equal 100? It sure does. This is a right angle triangle. That's how it works. Let's look at another. So I got legs of 12, 11, and then hypotenuse of 16. So leg squared plus leg squared equals hypotenuse squared. Now, when you work through this stuff, I strongly suggest you write it out like this too. Write your steps out so then you can see if/where you go wrong. So 12 squared plus 11 squared should be equal to 16 squared. 12 squared is 144. 11 squared is 121. And 16 squared, let's do that trick I did from the last video. If we go up 4 to 20, we go down 4 to 12. 20 times 12 is 240. We went up and down 4. 4 squared is 16. Add that there. A lot of you are like, what the hell is going on? It's just a really cool way to get perfect squares. So 256. So we add these things together, we get 265 equals 256. Not true, which means not a right angle triangle. So you prove it using mathematics. Now, what about solving a right angle triangle? Now, yeah, I left a little piece off, but this has to be present for it to be a right angle triangle when you're solving for information. So that's there in this one, okay? So again, we're going to use the Pythagorean theorem, and you're going to see that square root relationship come into play here. I'm going to leave it question mark squared. You could write hypotenuse, doesn't matter. So sub in. So I got legs of 3 and 4. So 3 squared plus 4 squared equals, I'll write hypotenuse this time, squared. Well, that's 9 plus 16 equals hypotenuse squared. So 25 equals the hypotenuse squared. Now comes that relationship of what gets rid of a square root, because we don't want hypotenuse squared. So we're going to take this hypotenuse squared and we are going to square root it. That's going to give us just the hypotenuse. But if that's equal to 25, we need to square root both sides. Hypotenuse equals 5, so boom. So the relationship of squares to square roots comes right into play here. Let's do another. Now you can see I have a square rooted number as the hypotenuse. That's fine. That number exists. It's just a non-repeating, non-terminating decimal number, but the square root of 74 is a number. Be comfortable with that. Don't discriminate against it. It's lovely. It's nice. Never did anything to you. But you'll see now in this case, ooh, I have my hypotenuse and I have my leg. So algebra aside, I mean, this is a one-step algebra idea, but forget algebra for a second. Let's just think conceptually. If you add the two small sides together to get the big side, well, how do you get a small side? It's the opposite inverse operation of addition. So in this case, I have the hypotenuse. I'm obviously going to subtract the leg that I have, and that will give me the other leg. So now plug in. So the square root of 74 squared minus 5 squared equal to the leg squared. So here is what I was talking about. The squared and the square root cancel each other off. So 74 minus 25 equals leg squared. 74 minus 25 is 49. And now we have to square root both sides to get just the leg. We don't want leg squared. And would you look at that? The leg is 7. So there's a little bit going on here with our square root square relationship, but it's something that's really good to get comfortable with. And remember, the big message is getting rid of a square, you square root. Getting rid of a square root symbol, you square. They are inverse operations of one another. So let's look at this in context here. So I'm building this little shed in my backyard, and I have to buy plywood to cover this back, this side of my roof. Okay, and the thing is the roof stretches backwards 8 feet, but I don't know the height of the piece of plywood that I'm going to need, right? That distance right there. But you have these measurements that you took, and you know that the diagonal of the roof is covered by this right angle triangle of length 36 and 60. So what you have to do here is you do the exact same process. 36 squared plus 60 squared equals, so we're going to use the Pythagorean Theorem. These numbers are going to get pretty big, so I will use my calculator here. And watch this as well. We're not going to go into conversions, but just be aware that the board length is in feet and we are in inches. So there'll be a video at some point for conversions of inches to feet, but we're not quite there. So 36 squared is 1,296 inches. 60 squared is 3,600 inches. And that will give us our diagonal length squared. So 3,600 plus 1,296, we get 4,896. And then how do we get the length? We have to square root both sides. Now, this will not be a perfect squared number, so I will estimate it. It comes out to approximately 69.9 inches, which means it's going to come out to, let's round to 70 inches. Now, if you know your inches to feet, 12 inches is equal to 1 foot, and 70 inches is just short of 72, because 72 is 6 feet. So we're looking at a board length of just under 6 feet. That is just how you put this stuff into context. Trigonometry in the trades is used over and over again, and Pythagorean Theorem is just one minor piece of trick. So thank you for Pythagorean Theorem, squares and square roots. We're going to move now into our official section 1 for grade 9, which is operations with integers. And a reminder that integers are positive and negative numbers, and we are going to see how they interact with one another and the effect you get when adding, subtracting, multiplying, and dividing them. And then in the videos to come, we are going to move through fractions to exponents, all the way into algebra, equation manipulation, and beyond. So thanks for watching, and see you next time.